Hey folks, we are continuing our second run of the 15 most important topics slash um, technologies slash tools that you need to be familiar with to get ready for your DevOps slash SRE interviews. Before I start, please subscribe to my channel. That motivates me to make more videos for you folks every day. Okay, so today's topic is number 4, development or software coding and such things, right? So the question is, not that one. How do you approach writing code that ensures both reliability and scalability in a distributed system? Now, the answers that I'm about to give you are very general, and that's okay because they're not asking you to code or anything, um, but they're particularly um, powerful slash resilient if your code is going to run in a distributed system. So here we go. What are some of the key things that you need to have in your code when that's required? First of all, it has to be modular, right? So it can't be all in one. It can't be a monolith. It has to have pieces that you can put together so that in some cases it can be services and whatnot run in different microservices, but even within a service, your code has to be modular so that it's easy to read and understand and change. That's what modular means, right? Now, because you're running your code in a distributed system, means your code could be running it could be running um, in one machine, but it might require something from another machine, and so on and so forth. That's what's called distributed. Meaning you're going to have tens, hundreds, maybe even thousands of computers where your code is running and the little pieces are running. So you have to have error handling and retry. So if your code is depending on something else, maybe a file call, maybe something, maybe a data call, whatever, right? You have to make sure that you put in error handling there so that you know when the error happened, so you can grab it, and catch it, and not have your program crash, right? And you also have to build in retry. So let's say there was a network problem that lasted in half a second or whatever. You try to make the same call again in your code so that it recovers, right? It doesn't just stop and then that doesn't make a mess of things. Use circuit breakers. So what is a circuit breaker? This is a concept where in Istio and microservices and whatnot, where you say, if my code is reliant on another piece of code or something, right? And I am getting whole bunch of requests, too much, more than I can handle, right? Your code should be able to say, you know what, no more. I'm pausing your request until I can recover. A lot of times these are done through PubSub or queuing system or whatever, right? Whatever the case may be, your code should be able to have these circuit breakers where you can know I'm not going to take in all these requests and then actually cause problems downstream for other codes that depends on my code. So I'm going to make a pause. Graceful degradation. So what that means is when when you're relying on some other service and that service is slow, right? Your code should be able to handle that and not crash, right? Allow horizontal scaling. That means your code can run in 100 computers all at the same time. Means if we start with five virtual machines or containers, and now that's scaled to 100, right? Your code should not be such that it crashes or has problems because it's running on more machines than in the beginning, right? A lot more machines. Avoid single point of failure means if you have, in this case, we're talking about a code that's large, right? A code base even. So your code um, should run in a way where if one thing fails, it can have errors and retries and recover, right? So it doesn't actually crash just because one thing has a problem, right? So one part of the system can go down and your overall application should still be up and running. That's what it means to avoid a single point of failure. For example, one virtual machine goes down, right? That should not impact your code or application. Use data structures and algorithms that can tackle growth. So it's kind of same as number 5, right? But it's being more specific. right? So when you have your code and it uses a particular, you're choosing to use a particular data structure, say list or slices or what have you, right? Or maps or JSON, whatever, right? That and the algorithm you chose to implement the solution, both of these should be able to run when your application is heavily used. So let's say you go from 100 users to 100,000 users, right? Your data structure, your code should not fail because you chose a data structure that could not scale, or you chose an algorithm that did not work well in a scaled up environment. So these are some of the things that you need to pay attention to in your code when you're writing code that runs in a distributed system. When people say distributed systems, think of 1,000 virtual machines or 1,000 containers running the same code or same set of codes. I hope you found this useful, and I'll see you in the next one.